at your seat, do you see the big green line through your name on that desk? You don't. All right, so what's it look like?
It's what's up, Swan? Wait, is that what we already did?
All right, so no. So if we're talking about graphing, which we will be talking about graphing, I'm talking about y equals absolute value of x. And this is something I didn't realize until I was older, even after I did absolute value, of why the graph looks the way it does. What does an absolute value graph look like? Does anybody know? All right, let me ask you this. What does this graph look like? Straight line, right? 0, 0, 1, 1, negative 1, negative 1. So it looks, it looks something like this. So if I said that x had to be absolute value, well, that means take everything that was negative and make it positive. So it flips up to be positive. So the absolute value looks like this. 0, 0, 1, 1, negative 1, 1. So instead of this piece of the line being below, it's just flipped up above. And that's all absolute value is. It's taking the negative parts and making it positive, okay? Because that's what absolute value does, right? Anything absolute value is positive. No, you don't have to. Now, if I'm talking about just absolute value of x, this looks a lot like a quadratic we did before, right? But the difference in a quadratic is it didn't come to a point, it really kind of curved out, right? This comes to a sharp point because it's a line. It's just been reflected. Is everybody okay? All right. Hank, what's the domain of that absolute value? You got this. What? What's what you're guessing? Is what? All right, don't tell him this time. What's the range? The range is 0? You're exactly right. Is it a bracket or a parenthesis on that 0? Why? That's a solid line. It's included, so it's a bracket. All right. So this is what we call the parent graph. Sorry. That's like the, okay. This point that I have in blue here, what do we call that? The vertex. Just like with a quadratic and a parabola, that point was a vertex, this is still called a vertex. Okay, it's the origin on the Cartesian plane, but as far as on the graph itself of absolute value, it's the vertex. All right, not a lot with this other than this, and we're going to do some piecewise with absolute values. But let me show you how you graph them, because they won't just be the absolute value of x. For example, what if I have this that I need to graph? How in the world am I going to graph it? Here's what I'm going to do. First thing I'm going to do is find the vertex. How in the world do I do that? Any guesses?
I would input 0.
No. We're going to set what's inside. I'm going to put, if I put AB, do you know what I mean? What are we talking about here? Absolute value. So if you need to write out absolute value in your notes, so if you go back and look, you know what that means, write that out. So we're going to set what's inside the absolute value equal to 0 and solve. Wait. Right. So x minus 4 equals 0. So you're right. X equals 4. Okay, so that's the x part of my vertex, right? How do I find the y part of the vertex? Just like with quadratics, after you found x, you would put that value in, right? And in this case, since there's nothing else over here, it's just going to be 0, right? But we'll say, just so that this fits any scenario, plug in, find y. Yes. So what is f of 4? Well, it's 4 minus 4, which is 0. So my vertex here is 4, 0. Everybody okay there? All right. Remember, this is the point where it V's off, right? So now just the steps are going to be the same as whenever I graphed a quadratic. So now what I want to do is pick an x. Actually, yeah. Yeah. That's what I was going to say. You technically could, because this is just a line that's been flipped, right? So technically I could know that this had a slope of 1 and I could go up 1 over 1. Pick an x close to the vertex. Now, if you understand what Logan was saying about the slope, because you understand that it's really just a line that's broken two pieces, you most definitely may use that. The problem, you may start getting confused because these equations will start getting more difficult and more complicated looking as we go. Yes. Yes. The only time you're going to go down for a negative slope is if the negative sits outside the absolute value. It will. That's why I said it will just be down. It'll be like that. All right. Here we pick, what should we pick? We can pick 3 or 5, either one, it doesn't matter. I was just giving the example Logan was using. So, all right, somebody said 3. If I choose 3, then y equals the absolute value of 4 minus 3, which is the absolute value of 1, which is 1, right? Now my step's going to be the same as a quadratic because this is symmetric just like a quadratic. So I'm just going to reflect and connect. Don't curve this one. This one's not curved. And hopefully we'll do enough of these where you can see exactly what's going on when we add these numbers and subtract them and everything else. In fact, tomorrow we start transformations. Yay! You'll get your transformation project soon too. Yay! They can get skinnier and wider and everything, and you're still going to have an A that's going to determine that. But we'll get into more transformations with that than we will. Yeah. No, doesn't matter. Yep. And it's not optional this time.
It's actually not really.
All right, what's the domain here? What's the range? Let's do another. No, because you're not going to know how to do the piecewise. And I got to do inequalities. Y'all got that? All right, one more example, and then I'm going to do a piecewise, and then I'm going to do an inequality. Actually, yeah. Let's do. Are you sick? So what are you finding? The vertex, right? So I'm going to do absolute, what's inside the absolute value equal to what? Everybody okay with that? Yes, Mr. G, we got it. Thank you. What does x equal? -2. I'm going to plug that back in so that I can find the y that goes with that, right? So y equals 1/2 times -2 plus 1. Yeah. We haven't found it. We already know this is 0 because we set it equal to 0 and solve. So I got 0 minus 4, which is -4. So where is my vertex on this absolute value graph? -2, -4. Is everybody okay finding that? Speak now, forever hold your peace. The vertex is -2, -4. Do you see how we got that point? All right, so I'm going to put that point on here. -2, -4. Y'all okay? Now we need another point. Call it an easy point if you want to, whatever you want to call it. Stick close to the vertex. You don't have to, but it's easier if you stick close to the vertex. What do you want to choose? I might choose 0 for this one, actually. Maybe -1. Maybe you chose -1. The only reason I'm not choosing -1 is I know that it's going to give me a fraction, and I know 0 won't. But choose whatever you want, whatever your little heart desires. You would just go up 1/2. Right. Because it's a line, you could just do the slope, and you could do up 1/2, and you'd be right here. Or I could pick a point. Because I know I got to multiply whatever number I have by 1/2. And I wanted it to be a whole number. I didn't want it to be a fraction. Because this is slope, rise over run. Remember, it's just a line that's cut in 2 different pieces. I don't like Wednesdays. Today's Thursday, though. This is a sharp turn here. Can't tell. Yes or no? I put in 0. You can put in whatever you like. Charlie, what's your domain? Yes. That's right. What's your range? Mm-hmm. Look at you go. All right. Yes, no, maybe so. Yeah. If I went up. Oh, I put that point at the wrong place. You see what I'm talking about? I put it at 2 instead of 3. There's 3. So yeah, it gets the same point. Sorry, I counted wrong. All right, let's do a piecewise.
Let's go.
All right, here's where it starts getting harder. Okay. This one's the first piece should be easy for you, right? Why is that easy? It's just a normal line. It's just a plug-in, right? I'm just going to plug in this 4, and I get the point 4, what? -7, that's right. Open or closed? I need another point. What's a good X to pick for that first one? 3. Why 3? It's less than 4. That's exactly right. So I need one that's less than 4. So 3 is less than 4, so I pick 3. I'm plugging in. What do you get? Plug it in the first one. So -2 times 3 would be -6 plus 1, -5, right? All right, so 3. Now comes the new part. Okay, here's what I have to think about as I look at piecewise with absolute value. What's the important part of the absolute value graph? What's the most important part, do you think? The what? There's one point that's probably more important than everything else right now that you know of. In general, looking at the absolute value, what's this important part? That vertex, right? So here's what I have to determine, and here's where it gets a little, The first thing I need to do is say, is the vertex in my domain? And by domain, I'm talking about this inequality. Does the vertex fall in that range of numbers? Is the domain, the x part of the vertex, bigger than 4, is what I'm asking. Because here's what's got to happen, right? Tell me first, let's just pull this out to the side, x minus 3. Where's the vertex? Remember, I do x minus 3 equals 0, so x equals 3. Does everybody agree? 3, 0 is my vertex. That happens right here, right? And then if I pick another point, say 4, and plug that in, and right now I'm not worried about that restriction, I'm just trying to prove a point here to you. 4 minus 3, which is 1. So I have 4, 1. I'm just going to graph this whole thing. Remember that eraser method I showed you before? That's what I'm doing right now just to prove a point. So if I graph this absolute value without any restrictions on it, it's going to look like this, right? But now I can say, but wait, X has got to be greater than or equal to 4. So here's where it's cut off. So I don't need any of this, right? So it's just an open dot here that goes on forever. Well, here's why it's important. A closed dot. It's a closed dot. Did I say open? I'm sorry. Here's why this is important. Had that vertex fallen in, like, let's say my cutoff was here, then that vertex is in that range of numbers, and I have to include it. So I need to make sure. That's why I said, is the vertex in this domain? Is it included? Because I'll need to pick that up if it is. Does that make sense?
What do you mean if it was back there?
So,
You mean if it was like half
no. I can't, what I'm getting at is I can't just plug this in and then pick one more point that's bigger, because what if the vertex, what if this sat over here?
Yeah, that's what I was saying.
See what I'm saying? So if the vertex is there, I have to include it if it's in this domain restriction.
Yeah. So can't you just find the vertex and look at it? That's kind of what
You could.
Yeah,
You could. Let's do one that the vertex is in that set of numbers and see what happens. So I can show you. Okay. For example, this is y'all's favorite kind. Are you ready to try it by yourself? I don't think, okay, you can. All right, my first question to you is looking at the first equation. Don't look at the restrictions right now, but just from this first equation, what is the vertex? Do that on your own right now. Find the vertex of that absolute value equation. What's the vertex? 0. No. Yes. 0 what? Everybody get that for the vertex. Okay, so set the inside equal to 0. 2x equals 0. So what does x equal? Divide by 2. And then plug that back in. Now, my question to you is 0 negative 4, is this point within this restriction? Why? How do you know it's in that restriction? What's less than negative 3? What's it tell you to look at? Look at the x. Is the x less than negative 3? 0 is not less than negative 3? Oh, no. Dang it. No, I didn't do it wrong, but I picked a bad example. I picked the same kind of example. I was.
We'll be fine, we'll say that.
Okay, so does everybody see what I'm looking for to see if the vertex fits in that restriction? Do you see why it does not? 0 is not less than -3. So it's actually a good thing. It makes it a lot easier because if it doesn't, I can just go through and graph like I've been doing. Plug in and pick one that fits the restriction and move on and go forward. And it's just like all the other problems. The only time it's an issue is if you go up, yes, it is in the domain. It is in the restriction. Does that make sense? Yes, we'll finish it. All right, so I don't need to worry about this because it's not in this restriction. Okay, so instead, what happens at -3? What is x? I mean, what is y? Plug it in. What is it? All right, look, 2 times -3. If the vertex is in, you'll in. Because it's not there. It's not, if your vertex is at -4, 0, and you're cutting off, sorry, 0, -4. I'm getting stumbled up. 0, -4. If this is my vertex, right? So whatever else my graph is doing all this. If you're cutting it off here, none of this matters, right? Only this part of the line matters. So I don't have to worry about the vertex. Does that make sense? So what I'm going to do, instead of worrying about this is the vertex, right? This is what you found to be the vertex, 0, -4. I'm not doing a good job with this. I can tell by the looks on y'all's faces because that's firing in my face. Okay. If I graph this entire absolute value, what would it look like? 0, -4 up to over 1. Does everybody agree? With no restrictions, that's what it looks like. Are y'all okay? Why? No. If I said graph 2x minus 4, I found the vertex. The vertex was 0, -4. I picked an x. I let x be 1. That means y would be 1, -2. You just regular, but if it comes out negative, you flip it to positive. Yes, but the negative has to fall outside the absolute value. We will after this. Because you can graph it one of two ways. It is because it's a line and it has a slope. Okay, so this is my absolute value graph, yes? Graph just that way, that's the absolute value graph. Now I go back and look at the restriction. Think about this as that eraser method we learned the very first time we did piecewise. The cutoff's -3. Here's 1. Here's 2. Here's 3, right? That's where I'm cutting the function off and I'm saying, okay, it doesn't go past -3. Here's my line, cut it off. Which side of the line gets erased? The right side, because it says x has got to be smaller than -3. So none of this is a part of my piecewise graph. In fact, it's only this. No, because what if my restriction was x is greater than -3? If the restriction was x is greater than -3, then all of this would be what I needed. The absolute value makes it harder because you have to take the vertex into account. That's what I'm trying to get to with you, is you have to take that vertex into account. When I do them, I find the vertex first and I look and I say, is the vertex in that restriction? Yes or no? If it's no, I'm just going to go ahead with plugging in like I normally do. If it's yes, I'm going to have to find the vertex, plot that, and then graph. Let's not make it piecewise right now. Let's just do one with a restriction. Let's do we'll coach Beck's classes out there right now. After this, then we'll take a brain break before we do inequalities. All right, we'll walk through this one together. I'll do this two different ways for you, depending on whichever way you prefer. Okay. First thing I'm going to do is find the vertex. What is the vertex of this? How do you find the vertex? Take what's in the parenthesis, in the absolute value, set it equal to 0. -1, right? How do I find the y part of that vertex? Okay, so y is negative y is 0, yes? All right, so right now, this absolute value has a vertex at -1, 0, right? Pick another point. What would y be if x is 0? Agree? Let's reflect it, and then we'll connect them. Right now, I'm not worried about that. I just want to show you the graph right now. Okay, now, that's exactly right. Now what I want to do is look at that restriction. That restriction says, but wait, x has got to be bigger than -3. Well, here's 1, here's 2, here's -3, so it says, here's the cutoff. But which side am I erasing? This time I'm erasing the left side. I'm saying none of this applies, right? Which way does x get bigger than -3? So this is my point, and this is my graph. I'd have been the other side, and I wouldn't have worried about the vertex. So let's find out, what's this point right here? This point should be -3, -2. I did. So you change what's inside, but that one on the outside stays. Yep. Yep. When do you take into account what? Say that one more
I
time.
thought we weren't allowed to put that -3 into.
Well, you still will because that's still your cutoff point. We just needed to know if the vertex was going to be included in that or not. Because that's going to depend on how many other points that I need. Now, if I did this the other way, if I plug this -3 in, right, initially, and I got -3, -2, and maybe this way is easier for you. There's my cutoff. That's the same way we've been doing where we plug in the restriction, right? And then I know that I need to go bigger. Okay, so maybe I plug in x equals 4. -2, just kidding. What happens at -2? At -2, it's -1, right? If I use this same method, what's wrong with the way with just doing that? It doesn't flip back down. You didn't encompass the vertex, and that's what you have to do there. Do you see why I can't just use the old method here? I have to make sure that because the vertex sits in here, I have to make sure I include it. So now that's fine, and I can leave that point. But because I know that my vertex is -1, 0, I need to make sure I include that because this is what this is going to look like. Oh my God. It's just which piece of the absolute value are you looking at? Take a break. Stand up and stretch. Double this up today.
You know I had to double it.
Double it or give it to the next person.
All right. Inequalities. Here's all you need to know. We're going to graph. We're going to graph the absolute value the same way as normal. Okay, so we're going to find the vertex. Yes. I'm trying to get it so I can give it to you. Let me tell you what you're going to do. Okay? If you have less than or greater than, you're going to use a dashed line. If you have less than or equal to or greater than or equal to, you're going to use a solid line. Okay, so maybe it looks something like this, or just regular solid. If it's less than or equal to, we're going to shade down. And if it's greater than or equal to, we're going to shade up. Bruh. What a lesson to sleep through.
Not hers. I need to see yours. Yeah, but like, why would I take that? If you practice the problem, it'll be easier.
All right.
Prepare.
Before I graph this, is my line going to be solid or dashed? Dashed. Am I going to shade up or down? It's going to be below. That's exactly right. I'm going to shade down. All right. Nothing to it. No. No. Let's do vertex first. What's the vertex? Good job, Charlie. -1 what? Yep. And what does y equal? Right.
Oh my God.
So the vertex.
You were doing so good.
-1, 0. Pick an x. Any x you want.
Yeah.
I would pick the same. Because it's close to -1. What happens when you plug it in? What do you get for y? Now what do you do? Reflect and connect. Just like we did with quadratics. All right, we said it's dashed. We went too fast? Okay, where did I lose you? Can you find the vertex? No. That's step one. Yeah.
So do we have to cut it off anywhere?
No, because there's no restrict. Now, if I said this, yes, you would cut it off. There's no restriction here, though. This is just, you won't restrict any inequalities like this. Just chilling.
Why are we shading down? We're shading outside.
Yes. All right, dashed. And we said shade down. So down would be outside, like this. You want to pass it out?
So that means I have to shade under. And we can just wait for it.
Trip what?
They don't got a good personality. I don't connect with them. That's why I don't like my
I'm gonna do, as I do this one, I'm gonna do it the way we did it in class with the other ones. I'm going back to the way, and then we'll worry about the vertex later. All right, here we go. Number 6.
Get a spray bottle and spray when you act so.
All right, here we go. All right, the first two, you just took a quiz doing piecewise like that, so you should be good on those, but let's run through it quickly. What kind of graph do I get when I graph f of x equals -1? Horizontal line, right? Horizontal line, straight horizontal line, cut off at -6, all right? So at -6, what's my y value?
Probably 1.
-1, that's exactly right. Smaller than -6, so maybe -7, what's my y value? And in fact, anything I plug in for x, I'm going to get -1, right? Right. All right, is my first point open or closed? Y. There you go, it's the line. All right, so 1, 2, 3, 4, 5, and 6, -1. Yes. -7, -1. So here we go. I've got the first piece of my 3 pieces on this piecewise graph. All right, let's move to piece 2. I'm going to plug in the 2 endpoints, and then all I have to do is connect there, right? Because it's just a line. So if I plug in -6, I got -6 minus 4, which is 2. So I have -6, 2. And then if I plug in 0, what do you get? -4. Open or closed? First one's open. Second one's closed, right? All right, so -6, 2, open. And then 0, -4 is closed. Yes?
Why is there like an arrow?
Because it's sandwiched between these two numbers, so it stops. All right, new stuff. Absolute value 2x minus 5. Let's plug 0 in first and just see where that first point is. If I plug in 0, what do I get? 5, right, which is just 5. So I get 0, 5. Is that open or closed? Okay, so 0, 5, 1, 2, 3, 4, 5. Now I need to decide what's going to happen at this point. Okay, where is your vertex for this particular absolute value? I plugged in 0. I will, but first I'm going to see if that other point needs to be my vertex or just another random point. I need to decide. So what's the vertex? Two and a half. Where is 2.5 on my graph? Between 2 and 3. Is that in this restriction? Yes. So I need to use the vertex. Okay. So if 5 over 2 is the x part of my vertex, what's the y? And you should get 0 because there's nothing else there but the absolute value. See why we had to use it this time? Because it fell. You okay? Okay, so I'm going to connect here, but the problem is since that's a vertex, I need another point, right? This is the point where it goes off in the it's symmetric. That's exactly right. So knowing that it's symmetric, how might I find another point? I could do that, or look at this one, right? I could go 1, 2.5, half, 1, 2. I could just reflect that point I started with. Where do you see 3, 0? Yes. Does that make sense? Is that way easier than the other way? Furthest left it goes. Negative infinity. See that blue line that's going to the left? That's my negative infinity. Now, as I start going over, okay, here's a stopping point, right? But this line picks up. So no break there. Keep going. This one breaks, no break there. So what's the domain? Negative infinity to infinity. Range is where it gets a little sticky. What's the lowest point on the graph? -4. That's exactly right. Now, as I go up, is there ever any place that I don't have graph? No, and in fact, it goes up forever because of this. So it's -4 to infinity. The last one went better than the first part. But look, here, I just need you to understand that the new part here is checking this to see if that's included or not. Do I need to include it or do I not need to include it as I plug in? In this case, yes.